I'm going to teach you how to create a machine learning model that detects malware with 95% accuracy. Hello world, my name is Data Mining Mike, and today we're going to create a malware detector in Python using a random forest. And if you want to learn more about how a random forest works, check out this video here. This video corresponds with a scholarly blog article, which you can check out in the link in the video description below. In the world of cybersecurity, this data comes from the conn logs, which are compiled in the SIEM, or Systems Information Emergency Management. I am highly confident at the end of this period of instruction, you will be able to take what you've learned and detect malware using your company's SIEM logs. That will blow your management socks off, and people are much more receptive to suggestions when their socks are off. And that's called value. But let's mine through the data in Python. I am not going to compile every single one of these cells because that would be too time intensive. I'm just going to go through this for the sake of instructional purposes only. And this cell, I import all the necessary or unnecessary libraries. In this cell, I import the data set. In this cell, I inspect the head. In this cell, I get all the descriptive statistics. And in this cell, I drop all the null values. And in this cell, I figure out what percentage of the null values are left per variable. In this cell, I figure out which variables are of what data type, because I want to make sure they're all integers. And in this cell, what I do is I label encode all of these values to get them to the appropriate transformations that which I want to use in order to see into this correlation matrix. A correlation matrix, or Pearson's correlation matrix, is a data miner's gold pan. And part of the game and the art of the science of making a scientific model is making sure that your model doesn't have, or your target variable doesn't have, any high multicollinearity with the predictor variable. So for example, our predictor variable is going to be, in this case, label. And in this case, we're going to be seeing that history is 38, 23 with original packets and bytes. What is going to be high is this right here. The proto-TCP and response P is both high. Response P is at negative 71% and proto-TCP is at 92%. So we know that adding these two variables, it's going to overfit the model, high multicollinearity, and that's one thing we're going to have to do is take away those variables, and that's what I'm doing. And in this section, we are visualizing using univariate, or one variable at a time, exploration. Here we see history. We see it's a bimodal distribution, or origin packets. It's generally kind of bimodal for label, of course, because it's a binary. And this is the Pearson correlation matrix after dropping the highly correlated variables. And I can tell that none of these variables have high collinearity or multicollinearity with the target variable. And in this portion of the code, we're going to be moving on to machine learning. And the machine learning, we're going to be starting with principal component analysis. So shrinking the data set down to its principal components, or eigenvectors, and then visualizing the eigenvectors in vector space with k-means. This is the method that I use when data mining, for advanced data mining techniques using unsupervised machine learning models. We can tell in this graph right here that the number of clusters necessary is going to be around 5. According to the Kaiser criterion and the elbow technique. That helps us reduce it. So the rest of the game is going to be what variables are going to be those 5 variables, and of those 5 variables, how are they going to give us the most accurate model. In this portion, we're seeing the data set in k-means, in vector space, in 3D vector space, and it kind of looks like a knife hand, like with a shocker. And then we can see it as it reorients to see 2 different groups, and we can see, yeah, there's definitely 2 different groups. It's already violating the null hypothesis for k-means that there is multiple clusters, and then we visualize it with 3 clusters and 4 clusters. And in this portion right here, we're moving on to the supervised learning, which is very, very powerful as well. And in this, we're going to be calling the random forest. Of these data sets, I found that this data set was the most efficient for yielding the highest scores. And what I do is I split it to X and Y with the target variable, which is going to be label. And I'm going to be dropping the target variable from the other set with the tuple test train split, which creates 4 separate variables, which I'm going to be using for the training and testing of this random forest regressor, which I call this cell right here. And I pass in X training and Y training. I run the predict, and now I go into the evaluation and scoring. I do the MSEs, or so mean squared error. You want it as close to 0 as possible. You want the R2 or R squared as close to 1 as possible. But this one just gives me an overall accuracy, which I generally tend to take, and I find it seems to be pretty accurate and corresponds with the other scientific explorations that others have done in this field. And that happens to be 95%. Let's visualize it. What is the receiver operator characteristic, or ROC curve? Well, the ROC curve was created during World War II. Signal operators would listen for or watch the radar, and they would see it hit. And sometimes they would see it hit like groups of birds, or they would see it hit a plane. And there was a person who was like, hey, we need to figure out, so we're not sending out and wasting gas and resources to go explore whether or not it's a flock of birds or an enemy squadron of planes. This individual decided to the receiver operator characteristic curve. It was a valuation metric to rate signal operators based on their sensitivity and specificity for false positives and false negatives. So that's kind of cool. It's a sidebar thing you can look into later. I am now highly confident that you can employ a malware detector on any labeled dataset. Be sure to like, subscribe, and smash that bell for more updates. Please leave all questions in the comments below. Bye!